This is a rather unique question on vectors, to be fair. So we've got x and b, fixed points in the xy plane, and their position vectors are given as shown. We need to state with reference to points a and b the geometrical significance of these quantities. So I think a diagram is going to go a long way here. We've got the origin, and maybe we have a point here a with this position vector little a, and then a point b over here with position vector b. So if I wanted to find a minus b, I would start from b, in fact, and go back to o. That would give me minus b, and then I'd go to a. So actually, it would give me this here. This is a minus b. So if I then want the magnitude of that, it's just going to be the length AB or BA, which is the same thing. If I want to add the two of them together, then I would actually create this little parallelogram. And if you ignored the half, you would go all the way to here. But if we have it, we're going to get to the middle of the parallelogram, essentially. In fact, the diagonals, this is something to be aware of, the diagonals of a parallelogram will bisect one another. And so AB is a diagonal of the parallelogram, and what we're going to do is get to the midpoint of AB. Now it says it's actually the vector, so I said it's the position vector to the midpoint of AB. Well, the mark scheme actually disagrees with me here, but I'm pretty sure I'm right. They say the midpoint of AB, but the midpoint is like a coordinate, whereas this is actually a vector. So I think we should be saying position vector to the midpoint. You'd get away with some other things. You could say midpoint of the vector, which actually doesn't really make any sense. But we must refer to A and B. You can't say midpoint of the vectors. You could say halfway between A and B. Anyway, don't stress about it, but there's a few different things that would be accepted. Okay, now on to this next part. It's probably the hardest, yeah, it's the hardest part of this question, I think. So we're told that a circle, P, is a set of points with position vector P in the xy plane which satisfy this. Now, I think we're helped a lot by being told that this is a circle. And so you can kind of see what the answer is going to be, I hope. Because we know for a circle it's going to be x minus a squared plus y minus b squared equals r squared. So it kind of feels like this is the radius over here and this is the center. And if you write that down, you'll be fine, okay, because it is correct. And the radius is. Now, if we weren't told it was a circle, then, I just wanted to kind of talk about that. You could still figure it out. So what I would do is I'd just maybe ignore this for the minute and say, okay, I've got my origin and I'm going to some different points, x, y, but when I find the magnitude, the length, it's got to be the same for whatever my x, y is. And if I draw these vectors going in different directions, we can see that we are going to form a circle. So it's kind of like coming out of it. And the magnitude is this a half a minus b. So that is why it's the radius. Okay, so I'm just trying to explain a little bit more why it's a circle. And then if we bring back in the other part, well, now this is almost, you can see it as translation. So whilst the center was at 0, 0, actually this vector is translating it to move it somewhere else, and that is going to be the actual center. So that's my justification a little bit more where these things come from. Okay, as long as you can in some way work out these two, actually the last part for 4 marks is not so bad because we're trying to find the Cartesian equation. All we've got to do is work out the radius and the center. So if I do a half, let me do it in a different color, sorry. A half a plus b, then it's going to be a half of 2 plus 4, okay, that's 6, and minus 1 plus 5, that's 4, so it's 3, 2. That is the position vector of our center. And then the half a minus b is going to be a half of the modulus of 2 minus 4, that's minus 2, minus 1 minus 5, that's minus 6. Now to find the magnitude of that, I just use Pythagoras' theorem. It's going to be 2 squared plus 6 squared, square rooted. That's going to be root 40. So it's root 40 over 2, which is the same as root 40 over root 4 or root 10. So that's my radius. And we're basically there because the position vector to the center is going to mean that the center itself is then 3, 2. And the radius is root 10. So that means x minus 3 squared plus y minus 2 squared is equal to 10.